What is malleabilization? Malleabilization is the prolonged annealing heat treatment cycle given to the white cast iron to produce malleable cast iron. The typical chemical composition of white and malleable will be same, that is approximately 2.5% carbon and nearly up to 0.5% silicon. This is a typical chemical composition we have taken. Actually, there is a range of carbon and silicon content, but the mean value of carbon and silicon content will be 2.5 and 0.5 respectively. So heat the white cast iron casting up to the temperature of 900 centigrade temperature slowly. This is the malleabilization temperature, and hold this white cast iron casting at this temperature for 1 to 2 days at this temperature. For 1 to 2 days. Followed by slow cooling to room temperature. So when you hold the white cast iron casting at the temperature of 900 degrees centigrade, at this temperature actually austenite plus cementite will be present in the microstructure. So what will happen? The cementite will get disintegrate into iron and carbon when you hold the white cast iron casting at 900 centigrade temperature for 24 to 48 hours. So due to this prolonged holding, the cementite will be broken into iron and carbon, and breaking of this cementite into iron and carbon is known as graphitization. So graphitization is nothing but disintegration of cementite into iron and carbon, or iron and graphite. So this is known as first stage graphitization. After completion of this first stage graphitization, now we are having two different possibilities. First, either you cool it down from 900 centigrade temperature or to room temperature in 1 day, that is in 24 hours, or you may cool it down from this temperature up to room temperature in 2 days. So we have termed this as the slow cooling rate and moderate cooling rate. From 2 to 3, cool it down from the 900 centigrade temperature. After 2 days, after prolonged holding at that temperature for 2 days, now bring down the temperature up to 25 in 3 days. That is, it will take complete 1 day. It is called moderate cooling. And second one is slow cooling rate, in which we will cool it down up to 25 centigrade temperature in 2 days. So it means the complete procedure will take 4 days in slow cooling rate, when you adopt slow cooling rate from 900 degrees centigrade temperature, and in the moderate cooling rate, if it is followed, then it will take 3 days. Total treatment will take 3 days. Following moderate cooling from 900 degrees centigrade temperature, austenite will get transformed into perlite. And finally, perlite plus graphite will be present in the microstructure. So it is known as perlitic malleable cast iron. And if we adopt very slow cooling rate, then what will happen? We will give an opportunity for the second stage graphitization also, because any perlite which is formed out of austenite, then the cementite present in this perlite will also get disintegrated into iron and carbon. So this is called second stage graphitization. So no perlite will be obtained in the microstructure. Finally, ferrite plus graphite will be present in the microstructure, and it is known as ferritic malleable cast iron. And suppose we adopt the cooling rate in between these two. Neither we cool it down in 24 hours nor it in 48 hours. Suppose it is 30 or 35 hours like that. Then ferritic pearlitic malleable cast iron will be obtained. Second stage graphitization will be just started, but it will not be over. So the intermediate cooling rate will produce the alpha plus pearlite plus graphite in the microstructure. And this structure is known as bull's eye structure because it looks like an eye of the bull. This is a typical microstructure of malleable cast iron. Irregular aggregates of graphite. It is due to the solid state reaction. And the background is totally white, so it is suppose ferrite. These are the typical applications of ferritic and pearlitic malleable cast iron for making farm equipments, chains, bearing blocks requiring some ductility and toughness and not high hardness and resistivity. Ferritic malleable cast iron will be preferred, and wherever more strength and hardness is required, then pearlitic malleable cast iron may be preferred for making shafts, axles, gears, etc. Black-hulled malleable cast iron is produced due to the dark appearance that is graphite at the center portion. So it is the result of decarburization at the center portion. It is simply ferritic malleable cast iron with decarburized surface layer, while white-hulled malleable cast iron, where white fracture will be seen from surface to center, right from surface to the center portion. The fracture portion will be white. It is totally free from graphite. Graphite is removed by the procedure of decarburization by heating the pearlitic malleable cast iron at 900 centigrade temperature in contact with some oxidizing material like ores for several hours. So structure will be approximately similar to steel in case of white-hulled malleable cast iron. It has got very good castability, higher corrosion resistivity, and economical than steels. So axles and gears may be made out of malleable cast iron in preference to medium carbon steel. Along with this advantages, it will have very good machinability and damping capacity due to the presence of graphite. Now about SG cast iron. Nodules of graphite are produced by adding a small amount of magnesium to grey cast iron melt. So as in the beginning we had seen that the typical chemical composition of grey cast iron and nodule cast iron will be same, that is 3.5% carbon and 2.5% silicon. But in this grey cast iron melt, if a small amount of magnesium is added, then it will convert the flakes of graphite into nodular shape. As you can see here, these are the nodules of graphite. It can be used for making crankshafts, gears, dies, bearing blocks, etc. Here also, the matrix may be obtained as ferritic, pearlitic, or the combination of ferritic and pearlitic, as in case of malleable cast iron we had seen, by controlling the cooling rate. Mottled cast iron, it is the mixture of grey cast iron and white cast iron. Cemented and graphite both are present at the different places in the microstructure. If the cooling rate adopted is very slow, it will result in the formation of grey structure, that is graphite, and if the cooling rate is fast, the microstructure will have combined form of carbon, that is cementite. So by adjusting the chemical composition and cooling rate properly, we can produce the combination of both these two, that is gray iron at center and white iron at surface. So this is the uh, numerical for the homework. Find weight percentage of alpha graphite and cementite in a ferritic perlitic gray cast iron having 4% total carbon and 0.4%